All right, good afternoon. This is Ms. Parks, and we are going to be doing section 5.1. It's about the natural base E. So, natural base E is this formula here, 1 plus 1 over x. It's used a lot for exponential growth and decay, but a lot of them also for like compound interest problems that have something similar to this. Okay, so if you take 1 plus 1 over x to the x power, so let's say it's 1 plus 1 over 10 to the 10th power, then you're going to get this. And then if you take 1 plus 1 over 100 to the 100th power, you're going to get this answer. And let's say we're all the way over here, and you get 1 plus 1 over 6 zeros, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So 1 plus 1 over a million to the millionth power, you're going to get this. As you can see, the numbers don't change very much after the very beginning. They even from 1,000 to 10,000 to 100,000 to a million, it's 2.712 or 2.71. 7 here, 2.718, 2.718, 2.718. Okay, so we really, it's the significant numbers don't change very much. And if you increase that to infinity, then that number approaches 2.718, 2818, and then the numbers after that are very insignificant and don't really affect it very much. It's kind of like pi. Pi has its own value, 3.14, etc. E also has its own value, 2.718, etc. Okay? You do have a button on your calculator that is an E. So on your calculator, you need to look for it. It's usually above the natural log button. So you have a log button. Above the log button, you have a 10 to the x. Those are inverses of each other. And then you have natural log, LN stands for natural log. And then above it, you have an E button. That's the button you need to become familiar with and learn how to use. So go ahead and put that in your calculator. Go E to the first. Then it should give you 2.718, etc. If you do E to the second, you should give you 7.389. If you do E to the third, it should give you 20.086. So take some time, get familiar with your calculator, and make sure you understand how to put that in your calculator. Now, if you can't find it, you might have a place in your calculator that has all the log values in it. And then in there, you might find the E through, it's like a menu. All right. So the first part of the problems that we're doing, we're not even using a calculator. We're just doing these as if they were regular variables. So we're just simplifying these. So simplifying does not include evaluate. Evaluate means you would be putting them in your calculator and getting a number. So in this case, we're just doing regular formula stuff. So that's E to the 9th. And make sure you don't make E capital. E is lowercase. Okay? For this one, I'm going to rewrite this just to separate this out. You probably don't really need to. But we're going to reduce this. So 16 divided by 4 is 4. And then we're going to reduce this. You just subtract the exponent. So that's E to the first. You have one more E at the top. All right, simple as that. The next one, it's going to become 3 squared and E to the negative 8x. 3 squared is 9. And then E to the negative 8x, we're going to move that to the bottom and make it E to the positive 8x because you don't want to leave a negative exponent. Go ahead and do all 6 of the next ones, please. All right, so we should have done those already. You should come back and check now. E to the 11th. For next one, 25 divided by 5, that's 5. And then 13 minus 12, that's 1. Here, 2 to the 5th power. And that's going to be e to the negative 15x, which is going to become 32 divided by e to the 15x. The next one, e to the 14th. This one, 24 divided by 8, that's 3. And e to the 8th divided by e to the 1st is e to the 3rd. You're subtracting exponents. 10 to the 3rd just means 1 with 3 zeros next to it. And then e to the negative 9x. So that will be 1,000 e over e to the 9x. All right. So that covers that part. Next, we're going to do growth and decay functions. We've already done these before. We just haven't done them with e. Remember, e is just a regular number that just happens to be in your calculator. So the hk is 0, 0. And then the way you can tell it's decay is because the exponent would be negative there. So this one. A is 1, or excuse me, A is 3, and B is E, because wherever the X is attached, that's your B value, okay? And that's 2.718. If you want to use 2.718, that's fine. If you want to use the E value, that's fine. Actually, I'm not. So I'm going to go ahead and use -1, 0, and 1. Add 0. Then that's my y-intercept, which is 3, my initial value. So that's here. And then this is our multiplier. So our multiplier is e, so you can multiply by e. Or you can multiply by 2.718 if you prefer. And if you're going this way, you're dividing by that. That gives you 1.1. And here you're dividing by e again if you wanted to do the next one. Let's just go ahead and do 3 points for these. I'm not going to have you do more than that. You can go ahead and just do 3. You can do the -1, the 0, and the 1 for all of these. Okay? So at -1, I'm at 1.1. And then at 1, I'm at 8.15. And then this will be exponential growth. And this is your HK. Your HK, remember that you can't cross the x-axis. Sorry that my graph is horrible. Not using my iPad for this one, using my computer, it's a little bit more difficult to draw. For this one, HK, 0, 0. A is 1. And then E to the negative 0.5 is the B value. If you rather put that in your calculator and use 0.606 as your multiplier, so you can use either one of these. Okay, you can use that, or you can use that. I don't care which one you use. -1, 0, and 1. Add 0. 1, that's my y-intercept. Then we multiply by 0.606. So at 1, 0.606. And then I'm going to divide. If you want to multiply by e to the negative 0.5, you can. Or if you want to multiply by 0.606, you can. So if I divide by 0.606, this gives me 1.65. And so I have 0.6 here and 1.65 here, and this is going this way. If you actually want to put a bigger number in there, you can. So if you wanted to use -4, you can actually put -4 times -0.5. That would make it e squared. And if you remember that when we did e squared at the top, it was like 7.4. So if you wanted to do that, you get a better idea of kind of where this graph is going. If not, that's okay too. As long as you do those 3 numbers here, I'm good with that. Okay. All right. Let's go ahead and do the next one. So you guys try it, the whole thing, and see what you get. Okay, you should be done. So 0, 0. A is 2.5. B is e to the first power. Here is e to the first power also. Remember, the x is not part of this. It's everything prior to that. So it's e to the first, which is 2.718. So I do my XY chart, and I'm going to use -1, 0, and 1. The A value is your y-intercept. And then e to the first is your multiplier. So if you multiply by 2.718 or by e, you're going to get 6.8. If you divide by 2.718 or by e, you're going to get 0.9. So at -1, we have 0.9, and then at 1, we have 6.8. And that's your graph. All right. Now I'm going to add something in that's not, they don't cover a lot in the book, but it should be in this section, I think, where we're going to talk about compound interest. So compound interest is when you are given a certain amount of interest per year, and then the next year you make more interest, but your interest that you made already makes interest for you again. So every time they pay you interest, that's when it's compounded. You earn some money. And then if it's compound interest, then your interest makes money as well, not just the original money that you put in. So P stands for principal amount. Okay, so P stands for principal. You spell it the same way you spell the principal of a school. And it just means the initial amount. So the initial amount of money you borrowed or the initial amount of money that you're loaning somebody, one or the other. R is the interest rate. It's always written as a decimal. So if you find that you're getting answers that just don't make sense, that it's like you put in 2,000, you're getting out 2 million, then your interest rate is wrong. Check that first. T is how many years your money has been in the bank. And N is how often that interest is compounded. For N, if it says weekly, then there are 52 weeks in a year. If it says monthly, then there are 12 months in a year. If it says quarterly, that means that they're going to pay you 4 times in a month. If it says daily, they're going to pay you 365 times. 4 times a year, excuse me, and this is 365 times per year. So we're going to be doing part A, quarterly, and we're going to be doing part B, daily. So those things apply to N, okay? Now, we're going to use this formula. Okay, so A equals P. P is the money that you have started with. So you actually started by putting $10,000 in the bank. Same thing on this one. The account pays 5.8% annual interest. It's always annual interest, just so you know. So that's going to be R 0.058. It says find the balance, so we're finding A after 5 years. So T is equal to 5 here. Same thing here. But the interest is compounded with the given frequency. So this one's quarterly, so that's why N is 4, and this one is daily. That's why N is 365. So now let's do this formula. 1 plus R 0.058 over N. In this case, N is 4. And then this is N times T. So 4 times 5, that's 20. Okay, and we're going to do all of this in our calculator at once, and I'm going to show you the order in which you should do that. Okay, now on this side, P, 1 plus R, N, which is in this one, 365, and then N times T is going to be 1825. All right, and then we're going to do all of this in the calculator all at once to get the second answer. Now, all right, so the order in which you're going to do these is the order of operations. So we got to do the parentheses first. So we're going to finish this up. Then we're going to do exponents. So you're going to do number 2, raise that to the 20th power after you get a total. And then number 3, you'll multiply by 10,000. If you did that correctly, you should get $13,336.47. This is money. You need to go to the nearest penny and make it sure that it's exact. This one should be a little bit more. So again, you're going to do everything in this parentheses first. You're going to raise it to that exponent, and then you're going to multiply by 10,000. You should have gotten a little bit more money here. If you haven't done that already, do that. Pause the video, and you should have $636.97. The dollar sign goes in front. I know you guys are used to seeing the dollar sign at the back. It doesn't go that way. All right, this last problem, let's go ahead and do this. So you deposit 5,000. That's how much you start with. Find the balance after 4 years. Annual interest rate. If you're not sure how to change that into a decimal, just divide it by 100, okay? And then compounded monthly. All right, so you need to write the original formula, 5,001 plus 0.325 over n. And then this is n times t, so n times t is 48. And then if you plug all that in, you'll have $5,693.14. If you somehow have less money after you earn interest, then something's wrong. And if you have a whole bunch of money, like 56,000, then something's wrong here. Okay? All right. We're not going to do any other ones for right now, but I just want you to know that there is a way that if it's compounded continuously, like instead of compounded monthly where they pay you monthly, they pay your interest, compounded continuously is this formula. You're not going to have to memorize any of these formulas. You're just going to have to use it. So we would use this formula instead, and you wouldn't have a monthly thing. All right.